All right, welcome back to the third video. Still working with, it looks like trig. It says create trig ratios to solve for the variables. Round your answer to one decimal place. Okay, so again, we're missing two sides. Now, if this were a 60-degree angle, we could use a special right triangle, but it isn't. And so we do need to use trigonometry. So we're going to use sine, cosine, and tangent. So sine is opposite to hypotenuse, cosine is adjacent to hypotenuse, and then tangent is opposite to adjacent. Okay, so looking at this picture, it says x equals, and so they want us to create the ratio and then solve. So in this case, I'm going to use this 50-degree angle. I'm going to identify my hypotenuse. My hypotenuse is 8 centimeters. And my adjacent to this angle will be the x, right? So here's adjacent. And then over here is opposite. Now, it's not that you can't use this angle, but again, like I said at the end of the last video, I would rather just work with the angle they'd given me. So since I'm going to use adjacent to find x, I will use cosine and the hypotenuse, right? So cosine uses adjacent and hypotenuse. So cosine of the angle, which is 50, equals adjacent over the hypotenuse. And then I would multiply both sides by 8. So in my calculator, I get 8 times cosine 50, which is 5.14. It says round to one decimal place, so that would be 5.1. Now, it didn't ask for cm, but I'm going to put it on there since they gave it to me. All right, for y, this time y from this angle is opposite, and I'll be using the hypotenuse, so I would use sine 50 equals y over 8, right, opposite over adjacent, opposite over hypotenuse. And I'll multiply by 8 again, and in my calculator, I get 8 times sine 50, which is 6.13, so 6.1. Now, here's a nifty thing. You could check this using the Pythagorean theorem, right? We could say 5.1 squared plus 6.1 squared should equal 8 squared, and check it. So 5.1, I'm going to go a little further so we get a little bit more accurate answer. 5.142 squared plus 6.128 squared equals almost exactly 8 squared, which is 64. So you can check your work. And then the missing angle, to find this missing angle, the three angles add to 180, and so it would be 180 minus 90, which is 90, and then minus 50, which is 40. So this would be 40 degrees. All right, now we're moving away from trig completely, and we're going into what's called function composition. So function composition is when you take a function and you plug it into another function. And that's what this is called. This is called function composition. You could also say a composition of functions. So be careful. When you see an open circle, that's function composition, f of g or g of f. I'm going to actually erase this right here because it looks like I made a closed circle, f of g or g of f. That's different than if you see this g of f, or sorry, g times f, f times g. A closed dot, those mean multiply, okay? And that's not what we're doing here. So function composition, what they want you to do is they want you to take g, the inside function, and plug it into f. So you're going to take this function, g, and you're going to plug it into f, wherever you see an x. So take the inside function and plug into the outside. Now, what do I mean by function, I should say? Let me finish this. Where you see an x. Now, What do I mean by inside and outside? So my inside is right here, inside. My outside is here. So like here, this would be my inside, and this would be my outside. Okay, so the inside meaning more to the right. Okay, so we're gonna go ahead and we're gonna write the outside function, f of x. Sorry, I'm gonna write 2x minus 1. And instead of writing, I'm gonna erase this and put the proper notation. So f of g of x, and that's another way of writing f of g of x, right, is to put the f right next to the g. So this is my inside function, and this is my outside function. I'm gonna write my outside function, which is f, 2x minus 1, but instead of putting x here, I'm gonna plug my other function into it, which is g. And g is 9x squared. And then do any kind of simplifying that needs to happen. So like right here, I would need to multiply. So that would be 2 times 9x squared. So it would be 18x squared, and then minus 1. So 18x squared minus 1. I'm actually going to do a second one. Let's do g of f of x. So that means g of f of x. So I'm going to this time write my outside function, g, which is 9x squared. And instead of writing x, I'm going to put the other function into it, which is f, 2x minus 1. Now this time there'd be a lot more simplifying because we'd have 9 and then 2x minus 1 squared is 2x minus 1 times 2x minus 1, and we'd have to multiply that together and then multiply our final answer by 9. So that would be in a little generic rectangle, right? You do 2x minus 1 times 2x minus 1. That's 4x squared, negative 2x, positive 1. So we would get 9 times 4x squared. That'd be minus 4x. They do not cancel. And then plus 1. And then I'd multiply everything by 9. My answer would be a lot more complicated. 36x squared minus 36x plus 9. All right. I hope I didn't go off the screen there. No, I didn't. Awesome. Okay. Next one, we're going to do another function composition. Again, f of g of x. So we're going to take our outside function, f, and we're going to plug g into it. So I'm going to start with f, which is 4x plus 7. And I'm going to substitute in g, 2x squared. And so that would be the easier one, right? So just multiply these together. That's 8x squared plus 7. Done. So 8x squared plus 7. Now I'm going to assume that if they didn't give you one that's difficult like this, where you have to square it out because you have to plug them in the opposite order, I'm going to assume that on the test, they're going to give you the easier case as well. All right, multiplying, but we're talking about imaginary numbers. So remember, I is not a variable. I is the square root of -1. So it's an imaginary number. And they want us to multiply and then find the product and then answer in the form of a plus bi. So they want the i's to come at the end. So I'm going to do a little generic rectangle because I'm multiplying two terms by two terms. So there'd be 2 minus 3i. And then -1 plus 4i. Multiply these together, that's -2. Negative times a negative, that's positive 3i. Positive 8i. And then that would be negative 12i squared. Now let's talk about I squared. So we know that I is the square root of -1. If I were to square both sides, these square roots would cancel. The square root would cancel with the square, and I would get that I squared equals -1. And so right here, I'm going to replace that with a -1. So I have -12 times -1, which becomes positive 12. Now, these terms will combine, and these terms now combine. So I have -2 plus 12. And I have plus 8i plus 3i. combine like terms, it's 10 plus 11i. So 10 plus 11i. And do write it with the I as the second term. We're going to do that again. So this is negative 4 plus 2i and 3 minus 5i. That's negative 12, 6i, 20i, and that would be negative 10i squared. And I'll remind you again that I squared is negative 1. So this is going to be negative 10 times negative 1, which is positive 10. And then we can combine like terms. Negative 12 plus 10 is negative 2. And then 6i plus 20i is plus 26i. All right, let me see how many more we have here. Oh, good Lord. There's still a lot left. I have my Math 3 review to do today, too. So you can see already we're at about an hour and 10 minutes just for Math 2. All right. Describe each transformation. So first, I'm going to write the standard form. Well, let me double check that you can see where I'm at. Oh, there. Okay. So the standard form, and it doesn't matter if you use F, G, H, I, whatever you want to use, right? I'm going to actually use Y. Y equals A x minus h squared plus k. This is called vertex form. And what happens in vertex form is this number, if A is negative, this will be a reflect across the x-axis. And then if A, absolute value, I don't care about the sign, if the absolute value of A is larger than 1, this will be a vertical stretch. And if the absolute value of A, again, I don't care about the sign just reflects, is between 0 and 1, so like a fractional value between 0 and 1, this will be a vertical compression. So here it narrows, right? It gets skinnier. And here it widens. And when I say it widens, I'm talking about from the parent function. And then H is a shift left or right. But you need to watch the sign because the sign on H will always change, right? So be careful. And then K is a shift up or down. Okay, so I'm going to identify A, H, and K. A is 2, H is positive 3. Be careful, it is positive 3. There should be a negative in front of it, so it's positive 3. And then K is positive 1. Excuse me. Okay. So since A is not negative, there's no reflection, so we won't mention a reflection. A, absolute value of A is greater than 1, so this is going to be a vertical stretch by 2. It means it's twice as narrow. And then shift to the right 3 and shift up 1. And you should put the word shift in there, but I'm running out of room. Okay, so vertical stretch by a factor of 2, shift right 3, up 1. All right, the next one, A is negative 1, H is negative 1, K is positive 2. A scale of nothing, right? Not scaling because the absolute value of A is 1. So there's no scale, but there is a reflection because A is negative, so reflection. And then shift left 1 and up 2. And the next one, A is not there, so it must be positive 1. Right, I could put a 1 there and it wouldn't change anything. H, is negative 3 and K is 1. Watch out, your sign on H always switches, right? That's why we had a positive, but it's actually negative, and that's because of that negative sign right there. So there's no scaling, no shifting. I'm sorry, no scaling, no reflecting, but we're going to shift left 3 and up 1. And then finally, A is negative 1/2, H is 1, and K is negative 4. Remember, the sign on K is always the correct sign. The sign on H is always backwards. So since A is between 0 and 1, absolute value, right? It's going to be a vertical compression. So vertical compression by 1/2. And then shift, this would be right 1, down 4. And I forgot to put in, it's also, since A is negative, we're going to reflect across the x-axis. So I had forgotten to put that in. I apologize. And so your answer choices are given to you. They say a stretch of 1/2, a stretch of 2, and so on. So they didn't even ask you if it's a compression or a vertical stretch. I'm sorry, my allergies are going crazy. If you could just give me 1 second. I don't want to pause, but I need to blow my nose. All right. And so make sure that you can match those with what I had described them. All right, next, what is the function in vertex form? Okay, so to write you're going to have to remember this equation. To find the vertex, to find the x coordinate, it's negative b over 2a, and then plug in for y. Okay, so we're going to find the vertex by using that formula, negative b over 2a. So the first thing I need to do is identify a, b, and c. I know we don't need c, but we're going to identify it anyway. And this will give us our h. Okay, this is our vertex. So I'm going to substitute x equals negative b, so negative b over 2a. And we said b was 4 and a was 2. And so that gives me negative 4 over 4, which is negative 1. After I find, so this is my h value. After I find h, I'm going to substitute it back in to find the k value, or y. Substitute it into your original equation. Y equals 2x squared plus 4x minus 3. And the value I'm substituting in for x is negative 1. And we always square first. So that's 2 times 1 plus 4 times negative 1, which is negative 4, minus 3. So it's 2 minus 4 minus 3. That's negative 2 minus 3, which is negative 5. And this is my k. So h comma k is negative 1 comma 5. And then we're going to write it in this form, y equals ax minus h squared plus k, where a was 2, and then h and k are right here 1 comma 5. Sorry, negative 1 comma 5. So y equals ax minus h squared plus k. And let's sub these guys in. A is 2, y equals 2, x minus h is negative 1, so watch your signs here, squared, and then plus k is 5. Y equals 2, and then this will become positive, so x plus 1 squared plus 5. And now it is in vertex form. Y equals, 2. They already gave you your y equals, so 2, x plus 1 squared plus 5. And I want you to notice, look, this would have been a shift to the left one. Yeah, the vertex is at negative 1. And then up 5, yeah, the vertex is at 1 comma 5. So if you were graphing this, you would start off by putting your vertex at negative 1, 5, right? But then you would, and normally if A were 1, you would just graph the parent. But since A is 2, you would take your parent, and instead of being out 1, up 1, out 1, up 1, out 2, up 4, out 2, up 4, it's going to be out 1, up 2, out twice as high, right? Out 1, up 2. So out 1, up 2, out 1, up 2. And then instead of being out 2, up 4, bless me, it'll be twice as high. So out 2, up 8, because instead of going up 4, it's going out twice as high. All right. Oh, guys, I apologize about my allergies. I'm sorry. All right. Now, I knew that graphing was coming next. That's why I kind of refreshed your memory about graphing. So if you know this is the parent function, x squared, then it's kind of easy to compare these graphs with this function. So this function is centered at 0, 0 because h comma k, they're not there. There's no h, no k given. They're 0, 0. And then a, the value right here in front of the x squared term, is 1. And so it's kind of easy to tell where the parent function is. But I'm actually going to use this as a graph since there's these quadrants here given to me, kind of. I'm going to use this as my graph, and I'm going to go ahead and graph my parent function. And for most of us, you guys have seen this over and over again, and you finally kind of caught on to it. But for some of you, you're still struggling with this. So if I graph this parent, right, I can pick whatever I want to for x. So if I were to substitute in -2 here, if I square -2, I get +4. So my value would be -2, +4. If I plug in -1 and square it, I'll get +1, so -1, +1. If I substitute in 0, I get 0. If I substitute in 1, I get 1. And if I substitute in 2, 2 squared is 4. This is called the parent function. And so what happens is a will make those y values multiply by whatever a is. So if a is like 4, they'll be 4 times taller. If a is a half, they'll be half as tall. Okay. And then h and k will shift your graph left and right. And then also if a is negative, it will reflect your graph. Okay, so let's go ahead and we need to simplify this guy. We need to put this one in vertex form. This one's the only one that's in vertex form, and we need to simplify this one as well. So let's go ahead and change this into vertex form. So that's what we just did before. We're going to use x equals -b over 2a, and here's b, and here's a. So this would be -6 over 2 times 1. So that would be 6 over 2, which is 3. That might be enough information, right? It might be. If there's no other graph that shows that the vertex has shifted to the right 3 units, but unfortunately it's hard to tell because this one, number 1, and number 3, they all both shift to the right, and it's possible that they both shift to the right 3 units. So I will need to substitute this back in to find my k value. Y equals x squared minus 6x plus 8, and I'm going to substitute in a 3. And so that's 9 minus 18 plus 8. It's -9 plus 8. That's -1. And I can kind of stop right there. There is only one graph that has shifted, right? H comma k is 3 comma -1. There's only one graph that has shifted right 3 and down 1. This graph shifted right, but it shifted up. This graph did not shift right, it shifted left from the parent, and it's reflected. This graph shifted right and down, so it must be this guy. This one has shifted left and down. So I can stop right there. That was enough to tell me. All right, the next one, I'm going to simplify. X minus 8 times x plus 8. I'm sorry, x minus 6 times x plus 8. So I'll do that, x minus 6 x plus 8, x squared minus 6x plus 8x minus 48. Okay, and so graphing, there's a couple different things you can do as well. Oh, I forgot to mention, C, this value, if it's not in vertex form, like this is vertex form, this is called standard form, C is your y-intercept. And I forgot to say that before, but it didn't help me anyway, because the two that I was deciding between were 1 and 3. And positive 8, this could have been positive 8, but this could have also been positive 8. So I couldn't tell, based off of this form, which graph it was. So this one, I have x squared, that'd be plus 2x minus 48. Now you may have to do what we did right here. It's possible that you have to find the vertex, meaning take negative b over 2a and find your vertex. But in this case, it says that your y-intercept is negative 48. So let's look at our three options that are left. Here's my y-intercept, not negative. Here's my y-intercept, not negative. Here's my y-intercept, negative something. It has to be this graph. Now, it could be, like I said, you might have to keep going and find your vertex. But in this case, I don't need to. I can stop. The only one that has a y-intercept of negative 48 has to be this one. All right, I'm going to do the next one. This one's already in vertex form, right? My vertex is, I'm just going to write it down, y equals x minus 6 squared plus 8. Here's my vertex at 6, comma 8. Remember, your h always switches. So vertex at 6, 8. 6, 8, it's both have been shifted to the right. Oh, and A is positive, right? So it must be upward facing. It has to be graph number 1. And then I know by default the last one's the graph number 2, but let's talk about that. If we start to multiply these together, right? If I say, okay, I'm going to multiply x plus 8 and x minus 6, I'll get x squared, 8x, negative 6x, and negative 48. And that's going to give me x squared plus 2x minus 48. But then you notice that I have this negative outside. That negative is going to flip my graph upside down. My a value is actually negative. And so that gives me negative x squared minus 2x plus 48. It means my y-intercept is a positive 48, and it's the only one where a was negative, meaning upside down. And so it must be the downward facing graph. All right, another writing in vertex form. So finding that vertex must be really important. So I hope that you have that formula written down, that x equals negative b over 2a. And here's b. So negative, negative 4, watch your signs, and there's a over 2 times 1. So that's 4 over 2, which is 2. All right, so I know my h, I went off the graph, there's the camera there, there we go. 4 over 2, which is 2. Now I know that's my h value, h. Now I need to find k, and to find it again, I substitute it back in. So y equals x squared minus 4x minus 7. And so I'll substitute in what I found for h, which is 2. So that's 4 minus 8 minus 7. Negative 4 minus 7 is negative 11. And this is my k. And then remember, a was right here, it's 1. So y equals ax minus h squared plus k. Y equals, or f of x, right, equals a is 1, no need to write it then. X minus h is 2, so x minus 2 squared plus k, well k is negative, so minus 11. All right, let me check the time on my video. Yep, we're about at that time, so I am going to stop here, pick it up on the next video.